The number of connected IoT devices is growing, so how could you ensure a secure, efficient, and scalable wireless data transmissions in your projects, especially in infrastructure where billions of devices are creating high network traffic? We might have unstable connections, data loss, and overloaded systems, putting critical IoT applications in risk. Today, we're diving into IoT connectivity use cases with a focus on mioty, a cutting-edge, low-power wide area network, LPWAN technology, developed by Fraunhofer IIS. And their special method makes mioty really unique. So I'm curious to learn today, what is this method about and why is it a game changer for industrial IoT? What real-world use cases are companies already implementing here? And what are the biggest pitfalls in wireless data transmission? For that, I'd like to welcome Annalena Zottmann. She's Business Development Manager at Diehl Metering, and Peter Hedberg. He is General Manager of the mioty Alliance. Let's start now. Find all insights and resources at IoTUseCase.com. Let's go. Hi, Peter, and hi, Annalena. Nice to see you and have you here on the IoT Use Case Podcast. So, to start directly, Peter, how are you today and where are you at the moment?
So thank you, Madeleine, for having me and having us on board here. I'm fine. I'm in my home office in Lund, Sweden.
Ah, Sweden.
Where I usually sit when I'm not traveling.
Cool. So greetings to everybody who's listening from Sweden. So it's nice to have you here. And Annalena, where are you at the moment and how are you doing today?
Hello, also from my side, thank you for having me. I'm sitting very close to Nuremberg because I'm also in my home office here in a village, in a small one. So very close to the forests.
Yeah, nice. Annalena, to start with you and your background, could you give us a very short introduction? What are you doing and what's your role at Diehl Metering?
My name is Annalena Zottmann. I'm working since 5 years roundabout in the Business Development and Partners Department at Diehl Metering. I'm there in charge of IoT topics, so business model creation, but also having a look on market potential. So where can we grow and how can we grow when it comes to IoT topics? Mm-hmm. Due to that fact, I'm also part of the Business Development and Marketing Committee of the mioty Alliance, and there I'm the vice chair of this committee.
Nice. And Peter, can you give us some insights about you and your role and how you guys work together?
Yes, first of all, so I'm the general manager of the mioty Alliance. That role is to basically lead all the members and partners and so on towards the goal that we have, that mioty shall become a global accepted standard, basically, for wireless communication. Mm-hmm. And helping me with all these daily tasks, and especially in the market and, let's say, the promotion of the mioty Alliance and so on, I have Annalena as one of the key players here. And I'm really grateful to have her with me. She's always full of energy, full of good ideas, and really giving the mioty Alliance all she has as regards knowledge and energy. So really grateful to have her with me.
Cool. You're mentioning mioty Alliance, as an alliance, and there's also a technology, a standard behind that. So I guess we will learn about this and also what kind of use cases you could solve with that. But to talk a bit about the why behind, we are living in a world now where we produce massive amount of data, across all kind of infrastructures. I just did an episode with IoT Analytics, which is our partner. They say that the number of connected IoT devices has grown by 13%, I guess, and total of 80.8 billion devices worldwide, which is huge. And why it's now important to talk about those technologies and why we talk about low power wide area network technologies in this area.
Yeah, as you said, it's the whole area of IoT and smart solutions has been growing steadily. And when it grows steadily year by year, and then the numbers increase all the time. Looking at the LPWAN, low power wide area network part of IoT, it's still a fairly small part of the total IoT market, but still very important. And we've seen over the years, let's say the last 5 years or so, that LPWAN has really proven itself. So it might be small data points that you're transmitting, but very, very important ones. And I'm sure Annalena will be talking more about this as regards how they see it at Diehl Metering.
Yeah.
So as you said, there are more and more devices, more and more products out there, and more of them are speaking wirelessly.
Right.
And wireless is a limited resource as well. So if you have lots of stuff talking there on those wireless bands, those bands will slowly but surely get more and more congested. So we need to use really smart technologies. And that's where mioty will come in.
Right. And Annalena, you are now in kind of a double role, and Diehl Metering is a big leader in smart metering solutions, for example. So can you give us some example use cases, what's happening in the Diehl Metering world here and what kind of new challenges are coming up with that?
Of course, yeah. I think the answer is not that easy, because in the past years, especially utilities, which is our main customers, I would say, they saw data points just useful for billing processes, so to make their billing processes more efficient. Mm-hmm. But due to the fact that we have at the moment changing times, like sustainability gets more and more in the focus because of water scarcity, for example, but also that our society needs to be more energy efficient, for example, data gets more and more valuable. This is more or less the reason why low power wide area network technologies like mioty getting more and more important for utilities, and I would say in general for companies and for our, let's say, world, because we need to handle data very efficient. And for that, we need a very efficient communication technology, which is on the one hand side, not losing too much information in between. So this is the one thing. But on the other hand side, of course, is not consuming too much bandwidth, but also energy, so battery. Because if we have then, let's say, technologies which are very, very rude to batteries, then we are also not anymore, let's say, solving the problem of sustainability, because then we are having less battery lifetime or more battery volume. Mm-hmm. So we always have here kind of a chicken and egg problem. And for us as the metering, mioty is one of those IoT technologies or LPWAN technologies which we have in our product portfolio, is the future-proofest one, because mioty is solving all of those points which I mentioned in a very efficient way.
Yeah. Do you have some examples which helps me to understand it better in a practical way? What kind of use cases you could solve with this technology, or where is it getting relevant?
Well, as all LPWAN technologies, let's just first set the limits here. You cannot transmit super much data. So it has to be fairly small data points. With mioty, you can transmit 250 bytes in one message. What is then that? Well, if you look at what Diehl Metering are doing in water meters and so on, you need is it 100 bytes or so for all the data that you need to transfer? But you can then add some more data points to one message. So with that in the back of our mind, so to say, what we can do with these technologies, typically, smart city solutions. So where you have all sorts of installations where you monitor, it could be metering parts where you measure gas, water, or something like that. You can also have air quality measurements, indoor temperatures, indoor air quality. You can do parking sensors and smart waste. And so it's a whole palette of different applications and solutions that are relevant.
Okay, so these type of use cases are more related not to real-time data and like high-frequency data. It's more about when you need a data point, for example, once a minute, or we have silo applications, for example, or like simple use cases, but you need to transmit the data in the right way. But we are not talking about real-time data, right?
No, well, you can get like an alarm. You can have really low latency. Let's say you have an alarm function that you want to send out. So we have one member of the mioty Alliance, that's a company called Swissphone. They do safety solutions for one part that they work with is what they call lone workers. So if you have workers in let's say, chemical factory, so they're out there doing whatever services or so in that factory, and there's a gas leak. You need to warn them all immediately. There's a gas leak, get out of there. And then you can press basically a button and push that message out immediately with mioty. Or the other way around, if someone hurts themselves and they want to ping let's say the dispatch center, they can do that as well. Mm-hmm. So you can do almost real-time solutions with LPWAN, but I would say the majority of use cases are exactly as you describe it, Madeleine, that it's a more continuous gathering of data. Could be that you send data only when you go over a certain limit or a certain temperature or whatever it might be, and then you send some information.
Yeah.
But it's not online all the time, because then it's not low power. So low power wide area networks.
Yeah, I see. Can you describe what the maybe technical challenge is customers have to get this data transmitted in the right way? Because there are a lot of different technologies out there on the market. What I was thinking also about is that you're mentioning this telegram splitting thing.
So just touching on what you said here as regard telegram splitting, which is actually the core of the whole mioty technology. That is what makes mioty so different. So very briefly, if you do it, let's say the traditional way, you have the data, a data point with 10, 20 bytes or whatever it might be. Mm-hmm. You put that data, like a temperature, a GPS position, or whatever you're measuring, so to say. You put that data into one message, and then you transmit it. And LPWAN, we are on open bands, and there is lots of noise there. There are other things using those bands. You're allowed to use them.
And by noise, you mean the infrastructure, right? Like other devices.
Yeah, exactly.
Yeah, okay.
So when you send the message, you run the risk that you will actually be hit by some noise or some disturbances. And then that message will be corrupt, or parts of it will be corrupt when it reaches the gateway. With mioty, you take the same data, those 10 bytes, 20 bytes, or whatever it is, you split it into a number of sub-packets. And then these sub-packets are transmitted with a slight time and frequency shift. And this swarm of small sub-packets is coming through the air. And yes, some of them will be hitting noise. Mm-hmm. They will be hitting something that is disturbing and basically taking them out of the band, so to say. But a number of them will reach the gateway. And we can lose as many as 50% of those sub-packets, and we will still be able to recompose the message 100%. So this is really the big difference.
So it's really also a good learning what you say. I mean, there's a lot of noise and different, like massive amount of data, but then you have noise also in different infrastructure which are coming through. So it's really important to make yourself familiar how to transmit the data in the right way as you are in different infrastructures, right? So that's the possibility to use these technology to do it in a better way.
Yes. So I was saying in the beginning that Annalena, she has some really good examples, because Diehl Metering, they're working with numerous wireless technologies. When they do the real life trials and tests and comparisons, you really see the difference.
Yeah, so I just need to grab a good example to explain it in a good way. But I think one of our most prominent example would be a pit installation readout example, because we did one field test 1 to 2 years ago in the capital of the Czech Republic. And there we installed one of our gateways. So we have a multi-protocol gateway, which can operate OMS, LoRa, and also mioty in parallel on one antenna slot. So it's a very, let's say, comparable situation what we can create through that, because we don't have some shifts in the antenna settings when it comes to the signal reception. And then we took our water meters. We were also equipping them with some receiving boxes, one with mioty, one with LoRa, and we installed them in different pit installations. And when we are talking about pits in the water metering area, then I'm really talking about boxes under the earth, more or less, with concrete walls and a metal plate on the top. So let's say it like that. It's the worst case for wireless communication. Mm-hmm. We saw that mioty was able to receive all water meters up to 2 kilometers distance, and LoRa was stopping after 200 meters. So you see here really the performance differences when it comes to mioty versus LoRa in that case, especially for utilities. Such a setting would mean, when they would do the whole city now with LoRa, that they would need to densify the network very heavily and put there more and more smart ways of doubling the signals. With mioty, you just build up once a network, and then you can stick to this network, and you don't have to densify networks. So you have once an investment, and you don't have to put more and more gateways into the field. It's really a future-proof technology, And it's not just future-proof in case of communication and receiving of signals and data points, but also future-proof in case of investments.
Right.
So if you do once your investment, you can stick to it. So you don't have to put further things into the field.
Yeah, investment. It's a big topic for a lot of customers out there, I guess, because some customers have built different networks with different technologies. And this is like good to learn that the technology is also not even better in the field test, but also scalable for different use cases, what customers want to set up. Is there a range of devices where this works better? Or do you say, oh, hey, it doesn't matter because our devices from Diehl Metering are in the field in every industry. So it's a technology which would work for everybody? Or is it like, do you see the range of devices there where you say that's good with these devices?
Maybe let's put it that way. If you have a small POC, you can go maybe with all of those technologies which are on the market. But if you want to really scale your projects, then you need to be really sure which technology you are selecting. So it's more about your future idea of your usage of your network and also about the amount of sensors which you would have in field in future. So in our context, so in the demetering, water metering and thermal energy metering context, it's always coming with mass sensors in field. So we always have thousands of devices in a specific area.
Right.
But of course, when it comes to industry, you have maybe first step a few sensors which are below, 10 devices or something. And then you're scaling up to a few hundreds, and then you're scaling maybe up to a few thousands. But after a specific point, you're getting your problems and your limitations because you also have there the reflections and the interferences and so on. And here you always have to think about what technology offers you the most proofness for the future.
Yeah. Can you explain why also Fraunhofer is involved here? Because there's a big background behind this. So can you explain a bit the role of Fraunhofer and why these players are working into this field and on this standard?
So Fraunhofer, they invented mioty. So they have the key patents. There are some others that have some patents as well, but the invention was made by Fraunhofer IIS, Institute for Integrated Circuits. So that's why they're interested, and they want to make sure that the mioty gets commercialized in the best possible way. And that's where the mioty Alliance comes in as the vehicle, basically, to bring this out into the world.
Okay, I see. A lot of people listening up also to this podcast are curious to learn how to set up the use case in the right way. And when I, as a company, want to set up a use case now with mioty, can you explain what the whole solution would be, or how you would integrate the technology in different devices? Maybe we could talk a bit about the realization and the methods behind how to use this technology.
The first question is if you want to build something from scratch yourself. If you go to the mioty Alliance website for developers, you find instructions there, what type of hardware you should buy and so on, and where you can download some software on GitHub, etc. So that's one way to go to sort of start exploring and so on, depending on how, let's say, technically savvy you are. Then you can also buy evaluation kits that are basically complete with gateway and some sensor nodes, and you will have backend tied to it and everything. So you can just go out there and basically test in your own environment. And there are some steps in between as well. There is now, even though mioty is a young technology, there is an ecosystem that is growing quite fast, and in all parts, I would say. We all know that it's really important that you make it easy for someone to try it out. That said, it's an interesting discussion when you talk about testing stuff, because if you do a test, let's say I want to compare mioty with the other technologies. So you're setting it up, you put some sensors out there and in the backyard or wherever, and you compare mioty with LoRa and Sigfox, and they will all work. That's the thing.
Nice.
But then when you start deploying, so let's say you start with 10, and then you go, okay, this works. And then you deploy another 100 or so on, and it's still working. But then when you start really getting a lot of devices out there, you will see limitations, not with mioty, but with other systems. And that's where the pain starts, basically, because you will have to densify, you will have to put out more and more gateways, and you will be ending up in a never-ending spiral that's where you see the big difference.
Okay, nice. Yeah, what you're just mentioning, I will just put the link in the show notes. So everybody who is interested, please feel free to browse through the website and see how other users are setting up this technology in the right way. And I was also curious to share some best practices here. So I don't know, Annalena, could you share some best practices from the metering side? Are there some advices or best practices where you say, hey, when you want to start a similar project, what should I be aware of while setting up these kind of projects?
Yeah, one of my most favorite projects is, I would say, the Energie. So local project here in Nürnberg, and they faced some problems with their current network setup. So they were not getting the signals like they expected it. What they did is they installed a multi-protocol gateway, which means they keep their, let's say, their sensors, what they nevertheless have still in field, and they put in parallel mioty. So that means for all the new sensors, for all the, let's say, future installations, they decided to go for mioty. And for the older things, what they have in field, because for them it was like the best thing to go in the past years, to go with LoRa in that case, they can keep until it's overdue, and then they can decide again what technologies they want to have in field. But for now, for them, the multi-connectivity approach is the right one. I would say if an end user already has something in field, I would never say kick everything out of your installations, but think of a multi-protocol installation and approach, because then you are future-proof. Then you can really go for the future and ensure that your network can handle also artificial intelligence on the edge, and so on, and so on, and so on, because we will transmit in future way more data. It's not the end, it's just the beginning. And for that, we need a communication technology which can handle those use cases and those developments. And here I really can say it's good to have Fraunhofer on board, because through that, we have always an innovation driver in the back as mioty Alliance, and also for the mioty technologies. And they will ensure that the technology can handle artificial intelligence, and so on, and so on, and so on. So everything what will come up in future, like satellite IoT, for example, they will test, they will do, and they will put it also on the mioty technology at the end.
Yeah, it's so nice to see that you have this great technology, which is also scaling. So we learned a lot about this, I would say, massive and robust system with this technology method, which is called telegram splitting, what makes the really, really big difference here. And then we're having a great standard, which is, by the way, also a European standard, right? So because I was just wondering, when you compare it to other standards, it's just European, right?
Yeah, it's German-based, and European.
Right. Yeah, okay, because of Fraunhofer background.
Yeah.
Peter, do you have any more reality examples out of your network? Because people listening up and say, hey, maybe you have some other examples, or maybe I could be also part of it as a partner in the Alliance. So can you talk about reality examples from your network?
So again, where mioty really makes sense is where you have big installations. So there are a number of projects and initiatives going on, not just with Diehl Metering, but when we're talking about smart buildings and smart cities, because that's where you really see the scaling. Now we have one of the founding members, IFM, they're coming out with a whole series of products for industry. So mioty has not been formalized yet, but we have we're on our way into what's called IO-Link, which is for industry, the standard for sensors. So there will be a big part opening up. There are already some stuff online, with one case now with Ford, actually, in their production of cars, where they're using mioty to really have safe, secure transmissions. I want to mention one thing, one really cool thing that one of our members is doing. It's Olympus. Olympus, it's a big company, the medical device part that is part of the mioty Alliance. And they do these pretty nasty equipment for surgery, basically. I don't want to go into any details there.
Yes.
But anyway, they want to pick up a few data points from these very, very highly advanced pieces of equipment so that they can make sure that they're used in the right way and so on. The problem is this equipment is usually inside operating theaters. And operating theaters in hospitals, normally they have walls and floor and ceiling lined with lead. So getting a signal out from an operating theater is really difficult. And they tried all sorts of wireless technologies to do it, but they couldn't make it work until they tried mioty. I don't have a real status update on that, but I know that they're really working on this, and they see this as a great opportunity for them to actually solve this issue.
Okay, cool. Yeah, so really nice to see that so many examples are out there using your technology. And also, please stay tuned with IFM, because a lot of new, also here in this podcast, things are coming up also with IFM this year. So stay tuned also in this podcast, because we will do a special episode with that. Last question for today. So we just talked about like satellite technologies and some new things coming up. Where do you see the future with this technology, or LPWAN technology in general? I mean, Annalena, you just started also by telling what's going on there. So do you have any additional things you see here in the future with this technology?
So yeah, in general, like I mentioned before, there are different trends and things ongoing in the IoT world. And one of those are, of course, AI. And I would say AI in different flavors, so on the edge, but also, of course, still in the software. Of course, this is also something where we will still have improvements and developments. But beside that, what we already do with mioty is satellite IoT. So there are some research projects already ongoing in Africa, for example, with mioty to protect their animals. And there is, of course, also further things ongoing like indoor positioning with mioty. So Fraunhofer does also some research. Maybe, Peter, you have something to add here?
So it's actually not just indoor, it's outdoor positioning as well. And it's due, again, to the robustness and unique way that mioty actually, say, how we transmit and receive messages. So you can get much higher precision thanks to mioty. I worked many years with Sigfox, and there is a system up and running with Sigfox where you do direct positioning from the network, so to say, but the precision is many kilometers. So you know which city you are in, but not much better than that.
Yeah.
You can maybe come down to a number of hundreds of meters, but that's exceptionally good. With mioty, we already now from initial tests that we will be down to 50 meters or less, probably even down to 10 meters or so. And that will open up completely new values and use cases because it comes automatically. So you deploy a water meter, let's say water meter, since we have Diehl Metering here. You deploy a water meter we have 50 of them in a big building, and there's something wrong with one of them. And you send someone out there, and he knows it's in this building, but there are 50 water meters. Which bloody meter is it I'm looking for? And if you get a position within 10 meters, you will know pretty soon which meter you're going to.
Right. So yeah, great examples. And when you think about AI, do you have anything like a sneak preview in the future? Which use cases would be possible with AI technology here? Do you see anything coming up? I mean, it's see in the future what use cases are working, maybe.
Ask ChatGPT and see what they say. But it's one thing that I know, and I know what we see is it's not tied to AI in that sense that it creates the value of AI, but an effect of it. I put the question at a conference a couple of months ago, a wireless congress. I put the question to both ChatGPT and Copilot, and I can't remember the third one, but the question was, what are the main challenges for wireless technologies in the future? And they all came out with the same answer: spectrum scarcity, meaning that the increase of wireless devices transmitting more and more data on the bands, on the radio bands.
Yeah.
This will put a big stress on those bands because those bands are a limited resource. And unless we use really efficient technologies, we will basically make it congested, like in Germany, like a Stau. That's what's going to happen on the band unless we're careful. And mioty is exceptionally efficient in comparison to the other technologies. So you can have hundreds, times more, or maybe even 1,000 times more devices in the same area if you use mioty in comparison to the others, because the band will not be congested.
Yeah. So thanks for this look in the future, but also like having really, really nice and great, valuable real world examples here. So thanks for that. And that's exactly where we start this episode, by talking about this massive amount of data coming up, and now where you really need to know how to transmit the data in the right way. And thank you so much for the insights to have now the opportunity to learn more about mioty as a technology and what the advantages are from this technology. So thanks a lot from my side. I have so many questions in mind, but I guess for today, I would say thank you for your time. Thanks for all these insights, great insights today. I would look forward to do another episode also and follow up on this. But for now, thank you so much. And I will put your contact infos also in the show notes. So please feel free to reach out to Annalena and Peter if you have any questions, and share best practices on that. And from my side, thank you so much participating in the podcast today.
Thank you for having us.
Thank you, Madeleine.
Thank you. Have a great day. Bye-bye.
Bye-bye.
Bye.